Section 2.4 Complex Numbers. Some people want it to happen. Some wish it would happen. Others make it happen. Michael Jordan. The imaginary unit I is defined as I equals the square root of -1. Or we can look at this as if I square both sides, I would have I squared to -1. Let a and b be real numbers. The number a plus bi is a complex number written in standard form. The real number a is the real part, and the number bi is the imaginary part. So your answers, you'll be asked to write in standard form. So this is your standard form. Two complex numbers written in standard form are equal to each other if and only if a is equal to c and b is equal to d. If you want to add or subtract complex numbers, for the sum, if we have a complex number a plus bi plus another complex number c plus di, then we add the real parts a plus c, and then we add the imaginary parts. And the same with the difference, except we're subtracting. So here we would have a minus c and b minus d. So for example, if we want to perform each operation, then another way you can look at this is as follows. We have 7 plus 3i plus 5 minus 4i. And basically, it works like if you were adding variables, we can add the two real parts together. 7 plus 5 is 12. And then we can add the imaginary parts together. 3i minus 4i is -i. You want to make sure this is in standard form, which it is. The standard form is the real part and then the imaginary part. Okay, so the next one we have 3 plus 4i. I'm going to distribute this negative in the parentheses. Minus 5 plus 3i. Gather our like terms, so 3 minus 5 is -2, and 4i plus 3i is 7i. Letter C, we have 2i plus -3 minus 4i. Distribute the negative, so negative is +3 plus 3i. Gather our like terms, so we have 2i, -4i, and 3i. So 2i minus 4i is -2i plus 3i is I. -3 plus 3 is 0. And I want to make sure I write it in standard form. So my real part should be first. 0 plus I. To multiply, we just multiply the same as we normally would. So -5 times 3 is -15. -5 times -2i is +10i. Letter E, we have 2 times 3 is 6. 2 times 3i is 6i minus 12i minus 12i squared. So we have 6i minus 12i is -6i minus 12. And then from the definition up here, we can see that I squared is equal to -1. So anywhere that we see an I squared, that's going to be equal to -1. So I'm going to write -1 here. Negative is positive. 6 plus 12 is 18 minus 6i. 4 times 4 is 16. 4 times negative 5 is negative 20i plus 20i minus 25i squared. Notice here that these are going to become 0. So we get 16 minus 25. Instead of I squared, I can replace it with a negative 1. So we end up with negative, and negative is positive 25 equal to 41. Okay. In standard form, this would be 41 plus 0i. Notice that your I imaginary parts here, this became 0. And that's going to happen if you notice our two complex numbers, they look the same with the exception of one is positive, or one is being added and one is being subtracted. So when we have the same real parts and the same imaginary parts with opposite signs, then these are called conjugates. And in conjugates, those middle terms will always become 0. And so what that means is, for example, if I had 2 plus 3i, then the conjugate is going to look the same, except I'm going to be subtracting. Since the middle terms cancel like this, then to get our answer, notice here that we squared the 4, gave me 16, and the square for 5 was 25. And so we could do the same thing. The square for 2 is 4, and the square for 3 is 9. So this is going to become 13. Well, you can see that if I multiply 2 times 2 is 4, 2 times negative 3 is negative 6i, 3 times 2 is positive 6i, 3i times negative 3 is negative 9i squared. The 6i and negative 6i cancel, and instead of I squared, I can write negative 1. So that gives me 4 plus 9, which is 13. Okay. Let's look at the next page. Complex conjugates are pairs of complex numbers such that the first one is a plus bi and the second is a minus bi. Again, the real parts are the same, imaginary parts are the same. The only difference is one has addition and one has subtraction. And when you multiply these together, your answer is just a real number. Just like we got on this side, 41 and 13. To divide the complex numbers, we multiply the numerator and denominator by the complex conjugate of the denominator. So here, write each quotient in standard form. So the first thing is to identify your conjugate of the denominator. Okay. So if I have 2 minus I, then the conjugate will be 2 plus I. Okay, so we're going to take our problem, 2 plus I divided by 2 minus I, and we're going to multiply our denominator by the conjugate and the numerator by the conjugate. So essentially 2 plus I and 2 plus I is just, if we're dividing this is just 1. So we're just rewriting the problem. So here I get 2 plus I times 2 plus I, and down here I get 2 minus I times 2 plus I. Okay, and so what happens is, let me just write this up here. If we multiply by the conjugate here, then we end up with a plus bi times c minus di. And down here, since these are conjugates, then we can rewrite this as c squared plus d squared. Just like we did 4 squared gave me 16 and 5 squared gave me 25. Okay, or if you want, you can multiply it out. So first I'll multiply it out. Okay, so I'm going to multiply 2 times 2 is 4. 2 times I is 2i. I times 2 is 2i. I times I is I squared. In my denominator, I get 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. And negative I times I is negative I squared. Yeah, there are like terms, so we have 4 plus 4i. And anywhere you see an I squared, we're going to replace it with negative 1. So we get a 4, 2i, negative 2i is 0, minus, instead of I squared, I'm going to replace it with a negative 1. So then we get 4 minus 1 is 3. And negative negative is positive, so we end up with 5. To write in standard form, it's 3 divided by 5 is 3/5, plus 4 divided by 5 is 4/5 I. Okay, so again, the shortcut would have been, in your conjugates down here, would have been to square the 2. 2 squared is 4. And to square the 1, which is 1. So 4 plus 1 would be 5. So that's a shortcut if you want to use c squared plus 9 squared. Okay, letter B. We need to multiply by the conjugate. So we have 1 minus 4i. The conjugate would be 1 plus 4i. Multiply this out. So on the numerator, we get 9 minus 19i times 1 plus 4i divided by 1 minus 4i times 1 plus 4i. So if we multiply this out, we're going to have 9 times 1 is 9. 9 times 4i is 36i. Negative 19i times 1 is negative 19i. And negative 19i times 4i is negative 76i squared. And your numerator, again, the shortcut would be to square the 1. So that would give you 1. And then square the 4, that would give you 16 plus 1 would be 17. Okay, so I'm going to write this shortcut over here. Would be to square the 1 and square the number in front of I. So we get 17 for the denominator. But I'm going to go ahead and multiply it out. 1 times 1 is 1. 1 times 4i is 4i. Negative 4i times 1 is negative 4i. Negative 4i times 4i is negative 16i squared. Gather your like terms. So we have 9. 36i minus 19i is 17i. Minus 76. Instead of I squared, I'm going to replace it with negative 1. 1, 4i and negative 4i cancel. Minus 16, instead of I squared, replace that with negative 1. So we end up with 9 plus 17i. Negative negative is plus 76. And negative is positive. 9 plus 76 is 85 divided by 17. So in standard form, this would be 85 divided by 17 plus 17 divided by 17i. We can simplify. So 85 divided by 17 is 5. 17 divided by 17 is 1. So my answer is 5i. When a is a positive real number, the principal square root of negative a is defined as follows. So whenever we have a negative inside the square root, we would be stopping, but now that we have these imaginary numbers, we can do some more work with them. So this can be written as the square root of negative 1 times a, since negative 1 times a is just negative a. And then what I can do is, since I know I squared is equal to negative 1, I can write down I squared times I, and the square root of I squared comes out as I square root of a. So from now on, whenever you see a negative inside of the square root, we can rewrite this and replace this negative with I squared, which comes out as I. And so we get this here. So square root of negative a is the same as I square root of a. Write the complex number in standard form. So the first thing you want to do is take care of these negatives. Since I have a negative here, I can rewrite it as I. It takes care of that negative. And then inside I have square root of 14 times, I have a negative here, I'm going to use I to take care of that negative, square root of 2. Then step 2, we multiply. So we have I times square root of 14 times I square root of 2. So that's going to give me I times I is I squared, and 14 times 2 is square root of 28. And then step 3 is to simplify. So I have I squared, square root of 28 can be written as I squared. And you want to find a perfect square for this 28. So for example, a perfect square would be 4 times 7. 4 is perfect. We can take the square root of 4. And so this would give me the square root of 4 is 2. I squared, and 7 stays inside the square root. Then you want to replace I squared with negative 1. So 2 times negative 1 is negative 2. So your final answer is negative 2 square root of 7. So again, first we take care of these negatives by replacing this negative with I squared, which comes out as I. So anytime you see a negative, we write it out as I. Multiply I times I is I squared. 14 times 2 is 28. The 28 can be written as 4 times 7, where 4, taking the square root of 4 would give me a 2. And then we replace I squared with negative 1. Okay, so let's try this one here. Again, first take care of these negative. So I get I square root of 8 plus I square root of 50. To add two radicals, the radicands, the numbers inside have to be the same. So first let's simplify 8. 8 can be written as 4 times 2. Okay, so the square root of 4 would be a 2. Since we have a 2 left in here, when we write 50, we want to make sure that we're using that 2 as well. So 2 times what would give me 50? 25 times 2. Square root of 25 is 5. And now we can add these together since they have the same radicand. So to add them together, we add the coefficients here. 2i plus 5i is 7i. And then the square root of 2 remains the same. Let's look at letter C. So I have negative 2 plus square root of negative 3 squared is going to be equal to, I'm going to rewrite this as the following. So I'm going to multiply this out. Or we can take care of this negative first. So I can rewrite this as I square root of 3 and negative 2 plus I square root of 3. So negative 2 times negative 2 is positive 4. Negative 2 times I cubed square root of 3 is negative 2I square root of 3. And the next one is negative 2I square root of 3. And I times I is I squared. Square root of 3 times square root of 3 is square root of 9. Gather our like terms, so we're going to have 4. Negative 2I minus 2I is negative 4I. Square root of 3 plus, for I squared, I'm going to replace it with negative 1. Square root of 9. Square root of 9 is 3 times negative is negative 3. 4 minus 3 is 1. And so this would be our answer. Okay, so how can we use this information to solve a quadratic equation? So first, we can try to factor this, but if it's not factorable, then you can use the quadratic formula. And so remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so if you have a quadratic equation, then your a is the number in front of x squared, the b is the number in front of x, and then c is your constant. So in this example, a would be 8, b would be 14, and c would be 9. So if we plug this into the quadratic formula, we end up with x is equal to negative b is 14, b squared is 14 squared, minus 4 times a, which is 8, and c is 9. Simplify. 14 times 14 would be 96. 4 times 8 is 32, times 9 is negative 288. 8 times 2 is 16. 96 minus 288 is negative 92 divided by 16. Notice that here we have a negative in the square root, so we can use imaginary numbers to simplify further. So we get negative 14 plus or minus the negative. I can take care of it by bringing out an I. And then I want to try to rewrite 92, so I can try some numbers. 92 divided by 2 would be 46, and none of them are perfect. So I can try 3. 3 doesn't divide 92, so if I try 4, 92 divided by 4 would be 23. So that's going to work, 4 times 23. So the square root of 4 comes out as a 2. Okay, so I can continue to simplify. Here I'm going to have negative 14 divided by 16 plus or minus 2i divided by 16. Negative 14 divided by 16 is negative 7/8. And 2 divided by 16 is 1/8. Okay, so my answers are x equals negative 7/8 plus I square root of 23 divided by 8. That's one answer. And the second answer is negative 7/8 minus I square root of 23 divided by 8. Yep, so these are my two answers. And what does this mean? When we're trying to solve, we're normally looking for these zeros. These are my solutions. Okay. And here, since you end up with an imaginary solution, then it means that there's no x-intercepts. So whenever you have imaginary solutions, that tells us something about the graph. And what it tells us is that the graph will never intersect the x-axis. So this graph might be somewhere up here, but it's never going to touch this x-axis. Okay, so the answer for this letter B is going to be x is equal to 1/3 plus or minus 2i. And so for extra credit, 1 point for quiz, I believe 5, but let me double check. For quiz 5. Show your work for letter B. Again, the answer you should get when you complete this is 1/3 plus 2i. If you would like to see the work, just send me an email. Otherwise, you can turn it in for extra credit.